Thanks for downloading a 3CR podcast. 3CR is an independent community radio station based in Melbourne, Australia. We need your financial support to keep going. Go to www.3cr.org.au for more information and to donate online. Now stay tuned for your 3CR podcast.
Hello and welcome to another episode of Lost in Science. As always, every week we bring you a lot of science and we get a bit lost in it, but we find our way out eventually. I guess only to get lost again the following week. Isn't that how it works, Catriona?
Well, you have to get lost to sort of work it all out and untangle it, but we get there.
Getting lost is part of the fun, isn't it?
Yeah.
Yeah, it's when you're looking around, you don't know where you are, but you're discovering new things. It's a good metaphor for science, I think. Speaking of science and Catriona, thank you for joining us. What have you got to interest and infotain us this week?
Chris, I'm talking about a certain type of waste, and I wonder, when I talk about waste in water, like rivers and lakes and things, what do you think of?
I think of, things like sewage, I suppose. Mm-hmm. I think of toxic waste, which is the big fear of the 1980s and the Ninja Turtles and stuff like that.
Yeah.
So maybe some sort of mutants and superpowers, that sort of thing.
Oh, I wish. Or like litter traps. That's what I think of when I think of waste in water.
Yeah, of course. Those big, litter traps you see in the river, yeah.
But I'm going to actually be talking about a waste that we can't see. It's pharmacological waste. So waste from medicines and other things like that are going down our drains.
Okay, so I guess these are things that they're chemicals that are probably meant to be quite potent, so maybe in small amounts they can still be harmful. Is that the idea? Yeah,
so it's like medicines that we're taking, and if we some of it out, it does go into the ecosystem.
Okay, that's a scary thing I hadn't really thought about as much as I should, I think. All right, well, I hope you've got some good news for us.
People are working on it. I think that's the good news.
Okay, good. That's good to know. Well, I look forward to hearing about, I don't know, some sort of hope for the future, perhaps, with that. I'm looking at the past. I got a bit suckered into watching a bit of a new TV show on Netflix that people were kind of a bit of an uproar about. It's a fringe archaeology show, let's put it that way, called Ancient Apocalypse. Oh. It was actually quite difficult to watch for a reason that is also the reason why I'm not going to really kind of criticize the archaeology involved in it, because the host of it has this particular theory that there was this advanced civilization in the last ice age on Earth that was wiped out by some cataclysm. But he has this tactic where he's aggressively hostile towards archaeologists, which a lot of these people do this, it seems. I also encountered someone today on the internet who was kind of claiming the exact opposite thing, which is basically that ancient civilizations like the Roman Empire didn't exist. And so, again, this person was going aggressive towards everybody else. And I've seen this with these kind of people in the past. It's sort of a preemptive strike that it's difficult to criticize them, because then it's like they've already said, oh, everyone hates me. And then
this is personal.
Or that the archaeologists are ignorant and closed to new ideas. So when the archaeologists criticise the science, they go, "See, told you so." And it's an interesting thing actually in archaeology, because I think it is actually particularly vulnerable to these kind of things. I mean, all kinds of sciences have their cranks, but when it comes to things like archaeology, people would much rather watch a TV show claiming, say, that Atlantis was real than one saying that it wasn't. So it's actually, it's quite vulnerable to these kind of claims because they get a lot of attention. And people are fans of this kind of fantasy stuff. But again, it makes it really difficult for me to attack. So instead, I'm going to look at one of the kind of scientific aspects of this claim, which involves the claim that there was an extinction event about 13,000 years ago that was caused by an asteroid or a comet hitting the Earth.
I'm sorry, Chris, I don't think that happened. That's not real.
Well, look, look, Catriona, I'm not going to get into that. I'm going to get into the science behind it.
All right.
You can say what you want.
I'll let you present the facts.
You can try and be your aggressive person. I'm going to present the facts as I see them, or that have been published in peer-reviewed research, because it turns out there have been some developments in this and some recent developments in this area, which turns out to be quite interesting. It's probably an area of prehistory that most people don't know much about. So it's worth talking about. There's a story that I bookmarked ages ago and I couldn't find a way to shoehorn it in, and I was like, oh yeah, now I can bring that up. And there's been developments in it since, so this is a great excuse. So yeah, that's me and that's Catriona, and yeah, we have plenty of science for you. So yeah, let's get on with the show.
So there's an accumulation of various contaminants in our water, especially given that we have emerging contaminants like microplastics, which I think a lot of people are talking about right now. But maybe one that we don't think about so much is pharmacological waste. And neither of these get filtered out by our current wastewater treatment plants because they're way, way too small. I mentioned that we can't see them. So I could easily go down a rabbit hole of all the different types of waste, but I'm mostly going to focus on pharmaceuticals and how it impacts both us and marine wildlife, because we're literally medicating our waterways with everything that slips through. So I kind of alluded to before that prescription drugs can enter our water supply when patients release traces in their urine, or some people even just flat out flush unused meds down the sink or the toilet. I don't know why that's why you dispose of them, but people do it. So 50 to 60% of the active ingredients of some pharmaceuticals, like estrogen in the birth control pill, they're flushed out in our urine. So they go through our bodies and then we're flushing out like 50 to 60% of them.
Is that like an unused portion of the medication? Yeah, okay.
Yeah. It's kind of like, the whole vitamins thing, and you're like, oh, if you take vitamin supplements when you don't need them, it's expensive pee. But the thing is, like with these pharmaceuticals, they're targeting receptors that are on our cells, and the drugs are designed to target them. But these receptors are evolutionarily conserved among different animal groups. So the same receptors that are on the cells of you and I are also very, very similar to the receptors on like other cells in the animal kingdom, like whether it's fish or turtles or anything like that.
Wow.
So yeah, these medicines that are developed for us, for humans, can also have the same or a similar effect on non-target species like fish. So firstly, I wanted to mention the psychoactive pollutant or antidepressant Prozac.
Yes. Fluoxetine, I think, is it?
Yeah, so Prozac's just the brand name. But
yeah,
traces of antidepressants are turning up in tissues of insects and spiders that live near streams. And the active ingredient has been found in water habitats all around the world, including here in Australia.
Wow.
And if you think about it, its purpose is to change the behavior and mood for people with depression. And it kind of is doing that in wildlife too. So Professor Bob Wong, I'm not sure if you're familiar with Bob Wong, but he's at Monash University and looked at what the exposure of fish to Prozac specifically would do. And his team found that it disturbed their foraging behavior or their ability to escape from predators, which, this was only done in a lab. But if you think about what it might do in the wild, it would potentially affect their survival if they can't, get food the same way, or if they can't swim away quickly. But another big one that I've already mentioned, a drug that ends up in our waterways, is the contraceptive pill. And the active ingredient is literally like synthetic estrogen. And this is known as an endocrine disrupting chemical because it disrupts the delicate balance of hormones in us as well as other animals. So in people, obviously that's the point. You disrupt the usually monthly hormone cycle so that women don't get pregnant. But what does it do in animals? So before answering, I kind of want to just point out that there are many types of endocrine disruptors in our waterways, and we honestly don't know what the impacts might be yet.
People talk about things like some plastics, like the BPA. Isn't that one of the ones that people point to as an endocrine disruptor?
Yeah, BPA is a massive one. So yeah, that's in plastics and fertilizers and things. So yeah, essentially they're all doing a very similar thing. They're mimicking and interfering with our hormones. So studies have seen abnormalities in the genitalia of both terrestrial and aquatic life due to the exposure of endocrine disruptors like the contraceptive pill and, Chris, as you said, BPA, essentially feminizing male fish and even alligators, turtles, and frogs.
Oh.
Yeah.
That's a bit... It's complicated because, like, you're talking about a lot of different kind of, I suppose, families of animals.
Yeah.
They have different kind of evolutionary histories and different kind of response to things. And, they're all being affected in this way.
Yeah. But if you, like, it must be that, these receptors for the hormones are just so basic in terms of evolution that they're so similar across all of these different groups. Because, we're very different to fish.
So that was, I was wondering, like, when you talked about the Prozac, is that, these laboratory tests show that it could have that effect. But you do kind of wonder, I guess, well, what is the actual level that is going to be out there? Because surely it's dose specific. But we talked about with these ones, this is actual seeing the effects on animals in the wild.
Yeah, absolutely. So over the past decade, feminine or feminized male fish have been discovered in 37 different fish species in lakes and rivers throughout North America, Europe, and other parts of the world. So yeah, like, people are actually seeing the effects and the impacts of this in the wild.
And that presumably will affect their reproduction and things like that.
Yeah, absolutely. So, for example, there are some types of fish that, in many species in across the animal kingdom, females often choose the males to mate with. But there's a certain type of fish species, and I can't pronounce the name, but essentially they go one of two ways. Either the females choose who they want to mate with, and usually they do that based on color, because they're like, oh, good color, good genes. But the other way is that a male can sort of penetrate aggressively. And so what scientists are seeing is that this is happening more and more. So they're going for the aggressive penetration, and so females aren't choosing anymore, and that's affecting the gene pool because you're eliminating that kind of the choice. Yeah.
Oh, geez, that's a complicated situation.
Yeah. And so, when you're getting all these fish that are being feminized, like, I'm all for feminism, but not like this. You're essentially, like, skewing the population. And this is actually how some people are looking into biocontrol, like forms of biocontrol for invasive fish species. Yeah, if you turn them all into, like, one sex, they can't reproduce anymore.
So, I mean, obviously, if that's something actually being used for biocontrol, and we are doing is unintentionally,
yes,
then it's pretty clear that's going to have major problems. Yeah,
and I might add, like, with the biocontrol, it's very controlled and also done in a completely different way. They're not just given drugs to fish.
So what do we know what can be done about this? Because I mean, I'm thinking about, for instance, how things would, say, get in waterways here in Australia, and like pharmaceutical drugs in particular, you would expect to go through the sewage system. You're saying they pass through our sewage treatment. They're not eliminated by those sort of plants. They then go out into the ocean. Is that what's happening? Yeah.
I think now that we're more aware of it, I think awareness is a really good thing. But because we've been aware of things like microplastics for so long, and PFAS, which is a really, really big one, that the forever chemical that people mention, it means that scientists around the world are actually looking for solutions, because once you know about the problem, you can start looking for solutions. And so with PFAS, for example, there are definitely ways now that people have found to break down those bonds and break down those chemicals. So hopefully now that we know that this is a problem, people, maybe chemists, can get onto it, like to figure out how can they break it down so that the active ingredients are no longer floating around in the water. But yeah, there's no, I guess, easy solution to stopping drugs and chemicals from entering our waterways. It's difficult to just get rid of or ban products, because sometimes when we realize that something is a pollutant, we ban it. But, these are obviously very useful to us. So if we take a look at the whole life cycle of these products, we can get pharmaceutical companies to do a bit more research into the impact of these products once we've taken them. So rather than just saying, we've made them, it's now on the consumer, if pharmaceutical companies kind of have a look at what happens after we take them, and take a little bit more responsibility as well. I'm not saying it's just on them, but they can certainly look at it. But also, we can be more mindful, especially when disposing of unused medications. Like maybe it was somewhat expired or whatever for us, and we're like, oh, well, we won't take that. But, it goes into the environment and might still have an impact.
I wondered too if it is things that we are peeing out, there's an opportunity to say more target the dose so that it's not being wasted. It's not going through the system as much, or something along those lines. Because you're right though. It'd be good for the pharmaceutical companies to take responsibility for it, but that's been talked about for a long time with plastics.
That's hard.
And they tend to push it back onto consumers. I think the plastics manufacturers. Yeah.
So I think it's kind of got to be everyone.
Yeah, but you're right though. The first step is being aware of the problem, and then being able to work on the solutions.
Yeah. I think the reason that the dose has to be a little bit higher is that, everyone's metabolism is so different. But I guess if we did do the research and what is the minimum dose we can have in a tablet that's effective for everyone.
Yeah. Or different ways of delivering it, or more
efficient ways. Yeah. I certainly know a lot of people who are looking into using machine learning and things like that to really work out the efficiency of drugs. So maybe that's a good use for it.
Excellent.
So a bit of hope.
Yeah. That's what we need.
Congratulations on your discovery, which may well prove to be among the most significant in the history of science.
I cannot accept half-baked theories that sell newspapers. I'm a scientist.
Who are you, who are so wise in the ways of science?
A most distinguished scientist, whose name we know, even in the wild of Transylvania.
Across Australia on the Community Radio Network, you are listening to Lost in Science.
You're listening to Lost in Science, and I am lost in the end of the last ice age. Ice ages happen on Earth. There is where there are more glaciers. I suppose the ice caps expand, we have more glaciers. You can see evidence, certainly, of past glaciers in many continents. The last ice age ran from around 115,000 years ago to around 11,700 years ago is kind of when it's considered to have fully concluded. Now, what causes them isn't well understood. There are many theories out there, some candidates, like there could be changes in the Earth's orbit. There are actually fluctuations.
Yeah.
There is the continents. We know they move around, and that affects things like, air and water flow, and various other things like that. And there is, of course, as we are very aware of now, the constitution of the atmosphere. But that's often hard to pinpoint cause and effect there in that. Often it seems like the atmosphere acts as a feedback mechanism, rather than necessarily being the original cause of it, because if it is the atmosphere cause, then you've got to figure out what caused the change in the atmosphere.
Yeah.
Look, there was actually believed to be a period, hundreds of millions of years ago when the Earth possibly went through a snowball Earth phase, and this is a case where essentially you get the cold temperatures kind of locked in, and it's hard to get out of a snowball Earth scenario. It's like a fully frozen Earth. That's not what we're talking about with ice ages. Ice ages are kind of not quite that extreme, and as I said, we do come out of them periodically. But look, whatever the cause is, the last ice age did finish, but something interesting happened around.
We're not still in an ice age?
No, it's we don't consider that. I mean, there are people that is debated sometimes with what actually constitutes an ice age, but you can see, from paleoclimate records that there was, from ice cores and things like that. That's something that we'll get to. There's something interesting happened around the end of the last ice age. So the temperature started warming around 15,000 years ago, but then around 13,000 years ago, it suddenly dropped. And this lasted then for another, say, 1,000 or so years. And this is the period that is known as the Younger Dryas. It's Dryas, and it's named after a flower, Dryas octopetala, that is found in the alpine tundra, and they're often found to be abundant kind of at the end of a glacial period. So, this is known as the Younger Dryas period after this particular flower. Little factoid there. And it's kind of a weird thing. So the main theory of what caused this is that possibly that when the glaciers started melting, they released a lot of fresh water into the oceans, in particular the Atlantic Ocean, which disrupted the Gulf Stream and reversed the warming. But there are others who have claimed that there was some sort of asteroid strike similar to the one that killed the dinosaurs 66 million years ago. Because a lot of the megafauna in North America, things like mammoths and things, went extinct around the same time. Now, this is another thing that's important to point out. This is basically a Northern Hemisphere story we're talking about here. So this Younger Dryas period is very visible in ice cores from Greenland. But you look at Antarctic ice cores, there is kind of that they show, indications of the past temperature. They show a dip, certainly in temperature around that time, but it's nowhere near as pronounced as in the Northern Hemisphere. And when we're talking about extinctions, that's kind of very much kind of a North America story we're talking about with this, because these animals did not go extinct at the same time all over the world. In Siberia, mammoths seem to have lasted quite a bit later. In Australia, for instance, some of the megafauna here, like the giant wombats, the diprotodons, went extinct quite a bit earlier than that. Now, there is obviously still a lot of controversy about human role in megafauna extinctions, because it often seems to happen after humans have arrived on a continent. But it can be hard to pinpoint cause and effect there as well. But, we're not really looking at that. We're looking at this question of whether there was an asteroid strike. And it certainly doesn't seem that if it was something, it didn't cause a global mass extinction, because it wasn't observed all over the world. And obviously it wasn't all animals, the mammoths died out, but a lot of animals didn't.
But you could argue that it's similar for, the big asteroid that killed the dinosaurs, right? They didn't all get wiped out at once.
Well, it didn't wipe out everything, but it wiped out a very large proportion of the species.
So this is a smaller proportion. This one you're referring to.
But look, the proponents of this impact theory have claimed to have found things like a black mat. They call it a layer of burnt material in their geological record, with what they believe are glass spherules. Sometimes they claim there are nanodiamonds, things that could be created by high temperatures and pressures, and rare elements like platinum. But all of this evidence is disputed, and people generally are not convinced until you find an impact crater. That was the case with the extinction 66 million years ago for the dinosaurs. The smoking gun essentially was the crater that was found on the Yucatan Peninsula in Mexico. Before that, it was kind of a controversial theory put forward by some physicists rather than geologists. A common theme we found in Lost in Science is that physicists like to come in and think they know better than everyone else. The main proponent of the Younger Dryas theory, though, I believe was a nuclear chemist rather than specifically a physicist, a related discipline perhaps.
And you can say this.
I can say
but
this,
I
yes.
couldn't.
But so look, I mean, some of the proponents have claimed that maybe it was like a comet that broke up and there was like it exploded in the air rather than leaving a crater. But others have disputed this, saying it doesn't really fit the claimed evidence. Others have questioned, like I said, the actual evidence themselves. So really finding a crater would be the thing that would justify this. And there's sort of some excitement in 2018 when there was a large crater found in Greenland, known as the Hiawatha crater, because it's in the Hiawatha Glacier. And this was discovered, basically, there was a project from NASA that was basically tracking changes in polar ice for obvious reasons. And some scientists noted there was a conspicuously semicircular section at the edge of a particular ice sheet. So they basically went over and they used radar to map this depression. They found it was this enormous crater about 300 meters deep. This was very exciting because you find a large crater that was previously unknown. Finding a crater anywhere on Earth is an exciting thing, especially as like a mysterious crater no one had seen before. But, the question then was also, when did this happen? Is this possibly the candidate for the Younger Dryas impact? And there were some indications that it could be the case. So the crater seemed to be quite well preserved, and like glacier ice really tends to scour the landscape. And so the fact this was still visible indicate they thought maybe it meant it was quite younger. And they also looked at layers in the ice and found that it was fairly good layers going back to around 11,700 years ago, which was the end of the Younger Dryas period. And before that, it was much more kind of jumbled up. But that's not, necessarily convincing episode evidence, because other people said, there could be other reasons for this effect. But it was actually looking good for a while, and like I said, in 2018, there was quite a bit of excitement about it, and the Younger Dryas Impact people got a bit excited too, saying that this has basically justified their theory. However, this was dashed a bit by some research published earlier this year, in fact, where they basically got minerals, sand and other minerals from the impact crater itself, and they did some dating using radioactive elements. This was done by two separate teams, some in Denmark, some in Sweden. The team in Denmark basically heated the grains of sand till they released argon gas, where they could look at the elemental composition of the argon, the isotope composition of the argon. And in Sweden, they looked at the mineral zircon, and they looked at the ratio of uranium to lead within this mineral. And this gives you a fair bit of good radioactive dating, gives you a fair bit of good idea of the geological age. And what they found is it was, in fact, wait for it, 58 million years old.
Oh.
So much, much, much older than our Ice Age impact. So it kind of really dashes the hopes. What's really interesting about this, though, study is because you think, okay, so these people have analysed it. Surely there's going to be still debate about their techniques. But the people who published the discovery back in 2018 were involved in this later study. And so there's not really any dispute. They agree. They're the ones who are saying that it could have been 12,000 years old. And now they agree. They were involved in the study that found it was 58 million years ago. So there's not much argument anymore.
Would they know what happened? If it's big enough that they thought maybe it could have triggered this event, 12,000 years ago, do they know what maybe it triggered 58 million years ago?
Well, basically, no, they don't. And that's a really good question. So, as I said, this was it's probably in the top 10% of size of craters found on Earth. But it's still not as large as the one that hit 66 million years ago. It was never believed, as said, to be a global extinction event. They were looking at more local impacts, and perhaps it would have had an effect on the ice and the melting of the ice in Greenland, and that's what could have caused this climate effect, rather than, say, a global catastrophe like the end Cretaceous one. I don't know much about 58 million years ago as well. I mean, clearly things would have taken a while to recover from the extinction of the dinosaurs. A lot of things. It took millions of years for life to recover from that event, and so maybe there wasn't as much large fauna to be impacted by it, fauna and flora. But look, now that they found it, I'm sure there'll be in the age of it, there will be a lot of work to try and find what climate impact it would have had. But yeah, it kind of dashes the idea that this was the smoking gun for the Younger Dryas. Now, if this Netflix documentary is anything to go by, the Younger Dryas Impact people haven't given up. They've gone back to their other kind of comet theory. And, it seems like the pseudo-archaeologists are, in the meantime, hanging their fedoras on this theory as their explanation for for their civilizations being wiped out. But look, until there is actual, proper evidence for it that everyone can agree on, I think it will still remain one of these minority, if not a fringe theory in archaeology.
Well, it could be somewhere out there, hidden, tucked away. We just have to wait.
It could well be there. It could well be there. It could just be, like I said, melting glaciers or some other thing. We don't know how. Like I said, we don't know how ice ages end anyway, so it's probably not that surprising if there was a bit of a hiccup at the end of the last one. But I'm sure that the puzzle will be solved eventually. And that's it for another episode of Lost in Science. Lost in Science is recorded for 3CR in Melbourne on the lands of the Wurundjeri people of the Kulin Nation, and it airs across Australia on the Community Radio Network with the support of the Community Broadcasting Foundation. We would love you to get in touch with us. You can email us at lostinsci@gmail.com, or you can find us on Facebook, we're Lost in Science on 3CR, or on Twitter, where we're at Lost in Science 1. You can find us on your favourite podcast app, where if you get the chance, please give us a good rating and review, as that will raise us up in the search rankings so other people can find the science. Or you can listen to us however you listen to us now. We're the same time every week when we all get Lost in Science!
Thanks for listening to a 3CR podcast. 3CR is an independent community radio station based in Melbourne, Australia. We need your financial support to keep going. Go to www.3cr.org.au for more information and to donate online.